Are you a WAEC, NECO, or JAM candidate? Now pay attention. This is one of the most dangerous questions you may be coming across, or you may have come across. You know, secondary school teachers rarely teach certain concepts in chemistry, and that is why you see students failing JAM, failing certain questions in chemistry. Now let us look at this question. What is the product of the reaction between propene and 1 mole of hydrogen iodide? This question looks simple, but it is also dangerous. Now let us examine the reactants. The reaction between propene. Propene is 3 carbon-membered alkene. It has a double bond here. That is why it's propene. Then we have hydrogen atoms, 2 here. This carbon has 3 bonds already. We fix 1 here. This carbon has only 1 bond. We fix 3 here. So this is the propene. It is saying what's the product when it reacts with hydrogen iodide. Hydrogen iodide. So it is easy for you to say that this bond will break and hydrogen fixes itself either here, or iodine fixes itself either here or here. In order to beat this confusion, there is a law that guides this kind of reaction. That law guides what is called symmetrical and asymmetrical alkenes, the addition reaction of symmetrical and asymmetrical alkene, and that law is called Markovnikov's rule. You know, the symmetry of a molecule affects the kind of product it forms, but this concept is somehow silent in our secondary schools. The symmetry of alkene is very, very important. For instance, this alkene is symmetrical. Why this one is not? Why? You will see why now. You will see why now. This is symmetrical because if you draw an imaginary line across the double bond, what you get at the right is equal to what you get at the left. But here, if you draw an imaginary line across the double bond, you get CH2 at the right and C2H5 at the left. So this is symmetrical. And this is asymmetrical. And the law known as Markovnikov's rule explains where the hydrogen atom goes when the hydrogen halide reacts with asymmetrical alkene. So Markovnikov's rule states that when there is an addition reaction between an asymmetrical alkene and hydrogen halide, the hydrogen part of the hydrogen halide attaches itself to the carbon that has more hydrogen atoms, while the halogen part of the hydrogen halide attaches itself to the carbon that has less hydrogen. So following Markovnikov's rule, we are going to consider these 2 carbon atoms that have double bond between them. This carbon atom has 2 hydrogen atoms attached to it, while this one has only 1 hydrogen atom attached to it. Therefore, when this bond breaks in the course of this reaction, this hydrogen is definitely going to the carbon that has more hydrogen, while iodine is going to the carbon that has less hydrogen. So how does it happen? How does it happen? It is simple. The bond breaks and we have CH3, then CH, single bond now, CH, you know, the bond has broken. Now, this hydrogen is actually going to this carbon that has only 1 the hydrogen is actually going to this carbon that has 2 hydrogen atoms, and you have it there. While the halogen, which is iodine, is going to the carbon that has only 1 hydrogen, and that is it. So this is the molecule, the product formed. And this product, the condensed formula is CH3, CHI, CH3. And that is, this is 2-iodopropane. 2-iodopropane. If you check the options, you will see the answer there. CH3, CHI, CH3. 2-iodopropane. And that is the answer. If you got value and this is your first time of seeing this channel, subscribe to my YouTube channel If you are on TikTok, click on the plus sign for more interesting videos. Do have a nice day and see you next time. Bye.